Hi, in this video we will learn how to perform substitution for definite integrals. Remember that in the indefinite integral case, we had the equality of two integrals. If we have an integral, an x integral of the form f evaluated at gx times g prime x, substitution for indefinite integral says that this is the same integral as fu du. But now if we have a definite integral, what should we do? So in this case, the assumptions are that let g prime, so g is differentiable, and g prime be continuous on the interval AB, the interval on which we are integrating, and f be continuous on the range of G. Then, well, this part, the definite integral, changing the integrand into u integrand is the same thing. The only thing we have to take care here is that we have to transform the limits of the integral x integral to u integral. We know that u is going to be equal to gx, so the lower limit, which is a in the x integral, in u integral is going to be equal to g at a, and upper limit is going to be g at b. So this means that, well, when it comes to the substitution, so for performing substitution for definite integrals, we need again change x integral to u integral. So well, those steps that I had there was three steps, three first steps. I'm just writing it as one step. Change x integral to u integral. While over there you need to do u, identify the pattern, set u to be gx, and then du is going to be g prime x dx, and then substitute everything there. But it's not done. You have to also change the limits of the integral, which in this case means that, while upper limit of x integral, if it is b, that means that x is equal to b. Now it will turn to u. Well, what is u? U is g at x. So if x is b, this is going to be g at b. And if lower limit x is equal to a, we need to do u at g at a to be lower limit of u integral. Okay? So not only you change x integral to u integral, you also do the limit, changing of the x integral limits to u integral limits. Okay, let's see some examples here. We have this definite integrals. When you look at these guys, you see, okay, there is a square root of something. That something is a good candidate for the substitution. So u is going to be 2x plus 1. Then du and dx are related by multiplying dx by the derivative of 2x plus 1, which is 2. But you see that there's no 2 here. Since 2 is constant, I can multiply 2 inside. So this is something like that. And then just to get rid of the effect of that 2 factor of 2, we divide the whole integral by 2. So this way, our integral is going to be integral of u du, but we have to change the limits. Lower limit of x integral is 0, upper limit of that is 4. From there, u is going to be 2 times 4 plus 1, which is 9. So upper limit of u integral is 9. And lower limit of u integral is 2 times 0 plus 1, which is 1. So now we change definite x integral to definite u integral. From here on, we'll use the fundamental theorem of calculus and knowing the antiderivative of, oh, I forgot this half up there, the coefficient that we added. I have to add it there. So then this is a power n 1 over n plus 1 u to the power n plus 1, and then we go from 1 to 9. This gives us 1 over 3 u to the power square root of u to the power 3, go from 1 to 9, and this gives us 1/3 of root 9 to the power 3 minus 1/3 of root 1 to the power 3. This gives us, so 3 to the power 327 minus 1 over 3, which is 26 over 3. Very nice. This one, we see that there is a sign to the power 4. So this, you can see this integrand as sine of x to the power negative 4. This is gx, and derivative of gx, which is sine x, is outside multiplied. So that is a good candidate to do substitution. U is sine x, du and dx are related by multiplying dx by derivative of sine x, which is cosine x. So this way we have, you see, cosine x dx is du. 1 over sine to the power 4, or what you see here, is going to be u to the power negative 4. How about limits? Well, x integral has lower limit pi over 6. From that, u integral is going to have sine of pi over 6, which is half. And x integral has upper limit pi over 2. So u integral is going to have upper limit sine of pi over 2, which is 1. From here now, you do 1 over negative 4 plus 1, u to the power negative 4 plus 1, go from half to 1. And this gives us negative 1 over 3. This is 1 to the power negative 3 minus negative 1 over 3 times 1 over 2 to the power negative 3. So this way we have negative 1 and then plus 1 over 2 to the power negative 3 is 2 to the power 3, which is 8. 8 minus 1 is 7 over 3. Okay? So that's how we apply substitution to a definite integral and turn it and solve it and find the final solution. Let's do another example. Here we are looking for integral of f of x squared plus 1 x dx going from 0 to 2 if we know that integral of f of x dx is equal to 6. Well, okay, let's look at this guy. F of x squared plus 1 x dx. Right away you notice that, okay, this guy has f evaluated at some function. Let's call that gx. And when you have this pattern right away, that is going to be substitution. And you already found what is the new variable u. It is x squared plus 1. du is going to be derivative of x squared plus 1, 2x, times dx. But when you look at the integrand, you don't have that coefficient 2. What we can do here is that we can multiply this by 2 and then divide by 2 to just get rid of that because it's constant. Now we have du here. So the integral turns to fu du. But since this is definite integral, we have to change the limit. Lower limit of x integral is 0. From there, lower limit of u integral is going to be 0 squared plus 1, which is 1. So this goes there. Upper limit of x integral is 2. From there, upper limit of x integral is going to be 2 squared plus 1, which is 5. And you see here, the value of integral from 1 to 5 of fx dx is equal to 6. Well, when you have integral, the integrating variable is a dummy variable. You can switch it and put anything you like. Anything you like. But exactly all x's must change to the same thing. For example, you can have integral of fs ds. You can have integral of fu du, fk dk. So here, this means that the value of this guy is exactly equal to the value of that, which is 6, but we have a half multiplied to that, so the integral is going to be 3. And we don't need to know what is the function. Just by substitution, we were able to evaluate that integral.